Welcome to solverfy.
Number 52 is a continuation of 51, so I will be only doing the pertinent bits. One relationship that we will need, considering this as a negative focal length, you're only going to get reduced images of real objects. So that's why the question hints at us that we want to, in these cases, have the objects be virtual, formed by some other piece of optics, either real or otherwise. And we also want to have negative object distances such that we can get enlarged images. That's the only way that this will work out. So we'll use the magnification ratio here, rearrange for our object distance, and then if we jump over to our lens maker's equation, and if we plug in for the object distance, that one, this becomes minus m over di. And finally, since we want to get the image distance, we just rearrange slightly to get di is equal to 1 minus m times the focal length. So for A, we are wanting to find how far it has to be for it to be magnified 2.5 times and be real. So that means that di is going to be greater than 0, and m is going to have to be greater than 0 for this to give us a real image. So m is going to be equal to plus 2.50. And then you just plug in for that. di, you put in what we have, and you see di is 75.0 millimeters, and do, which is given here, is minus 30.0 millimeters. So that gives us where the object needs to be placed for it to have this criteria from question 51. Now for for part B, it is kind of similar. What if the image is to be virtual and magnified at 2.5 times? Well, in that case, if it's virtual, then di is going to be less than 0, and since f is less than 0, m must also be less than 0. So m is going to be equal to minus 2.5. Plugging in, just like we did before, we first make the jump for di, and we get minus 175 millimeters, not meters, millimeters. And then plugging in again up here, we see that our object distance must be minus 70.0 millimeters. And again, if any of that wasn't very clear, you should also look at the answers from 51.